Hello and welcome everyone. My name is Rick Frage. I'm the sales director at SFT Canada. We are happy to have you all here from all over the world, from different time zones. So today the webinar is about it's an introduction to fiber reinforced polymer connectors, shear connectors, presented by Dr. Girish. So just a little bit about Dr. Girish. Dr. Girish has been working with us for about 9 months to a year now. He received his PhD in civil engineering from the University of Sherbrooke in Quebec, Canada. And before that, his Master's of Technology in Earthquake Engineering from the India Institute of Technology in Roorkee, India. He also he received the University Gold Medal in 2013 for Bachelor of Technology project on strengthening of reinforced concrete columns with external bonded fiber reinforced polymer from and that was at the Veer Surendra Sai University of Technology. His research interests include the behavior of structural concrete reinforced with fiber reinforced polymers, testing and characterization of fiber reinforced polymer materials, and nonlinear finite element analysis of reinforced concrete structures. Girish currently is a senior designer and researcher at SFT and also a MyTax postdoctoral fellow at the University of Sherbrooke. Since he joined SFT, he basically worked on different projects with us, including but not limited to structural slabs, walls, retaining walls, and different types of projects that he helped us either design from scratch or convert from steel structures to fiber reinforced polymer.
Thank you, Rick, for the brief introduction. And so let's start with the today's presentation. It is a very short webinar on the introduction to fiber reinforced polymer connectors. Now, through this presentation, I will give a brief overview of the properties of SFT connectors and its application, and I will go through 2 case studies to elaborate its present uses. So before starting our main presentation, I would like to introduce our company, SFT. So our products are mostly designed in Canada and manufactured in China by Sandok Industries Co. Limited, who are specialized in manufacturing of fiber reinforced polymers products. So we work with national and international engineering firm, and we work with them through the design process and help them with the fiber reinforced polymer designs standards, whether they are in Canada or in the United States. And our focus are on the parking facilities, water treatment plants, retaining walls, and which is mainly made of glass fiber reinforced polymers, and also the carbon strap applications. The SFT FRP bar is made of composite materials, and the composite materials are either fiberglass or carbon fiber. And it is manufactured by a process called pultrusion using a mix of recycled fiber and resins. And here the figure shows a microscopic view of the FRP bar. So there are 3 different types of fiber reinforced polymer bars available in the market. Now it is 4, but I am presenting only 3 here: carbon, aramide, and glass. And the 4th one is basalt, on which the research is still going on. And the stress strain plot shows how these FRP bars are compared with steel bar. And 2 points should be noted from this plot. First, the glass fiber reinforced polymer have lower strength compared to the other 2 FRP bars. And the second is the strength of all fiber reinforced polymer bars are higher than the steel bar. However, their behavior is linear elastic up to failure. So in our products, we have different types of FRP products depending on the project requirement. And some of the FRP bars we produce are straight bars, spiral, and stirrups for the transverse reinforcement, band bars, and glass fiber reinforced polymer shear connector, which is the talk of the topic today. The glass fiber reinforced polymer bar is widely used due to its production cost and have better tensile strain compared to the other fiber reinforced polymer bars. That's why most of our products are made from the glass fibers. The sum of the advantages of the SFT glass fiber bar over the conventional steel bars are: It have longer service life because of its corrosion resistance and therefore improved durability in harsh marine environments, such as construction near the coastal areas in North America cold climate. The FRP bars have better resistance against corrosion compared to the steel bars. And it have, as I told earlier, the tensile strength of the FRP bars are 2 to 3 times more than that of the steel bar. However, it have more tensile strength. FRP bars are lighter due to the low density compared to the steel bar. And due to the corrosion resistance, FRP bar are good for the harsh chemical environments as well. And it is neutral to the electrical and magnetic disturbances, usually useful for the applications such as airport, military applications, MRI rooms, and hospitals. The sum of the selected field applications of the SFTech FRP bars we have already done in Canada are GFRP reinforced concrete fiber flooring slab designed with SFTech glass fiber reinforced polymer bar, which was built last year in Halifax, Nova Scotia. And it can also be used for slab on grade. It is a non-structural slab and it is a not one-to-one replacement and save a lot of money compared to the steel bar in terms of labor and transportation. Another project shows the cast in situ precast sandwich panels, and they have used our glass fiber reinforced polymer bars in their project as reinforcement, and it was built in China. And in the right, it is a retaining wall built for the city of Montreal. The retaining wall is designed to dump snow with de-icing salts during the winter. And so they built this retaining wall with aseptic glass fiber reinforced polymer bar, which provided resistance against the chemical used in the de-icing salts. Traditional steel shear connectors are being used in bridge construction, or we generally call them stud also, at the interface plane between the glass in place deck slab and the precast girder to ensure the composite action for stronger cross section. But as we know that in the North American countries, as the bridge deck slab corrode over time due to the environmental conditions, these shear connectors also corrode and will need replacement, especially in Canadian winter, where de-icing salt is used. And the corrosion of this steel shear connector result in gradual loss of the composite behavior and strength of the composite action. So fiber reinforced polymer connectors have shown to be effective alternative to the conventional steel connectors due to its resistance against the corrosion. It is lightweight and also non-conductive and magnetic free. We'll discuss why the non-conductivity of the FRP is helpful. So with SFTech connectors, we have generally 3 different types of connectors. The type 1 connector is the SFTech thread connectors, which have a tensile strength of 700 megapascal, 180 megapascal shear strength, and tensile modulus of 65 gigapascal. The second type of SFTech connector is the SFTech flat bar with tensile strength of 600 megapascal, shear strength of 120 megapascal, and tensile modulus of 45 gigapascal. And finally, the third type is the SFTech thread shear connector, which have a tensile strength of 600 megapascal and tensile modulus of 60 gigapascal. And its structure is like a truss. And it is worth mentioning that all the SFTech connectors are made up of fiberglass. The shear connectors are used to transfer in-plane shear forces between 2 widths. As we can see in the figures, there are 2 concrete widths at the 2 ends. And the sandwich panels are usually designed as one-way structural slab, and shear forces are generated due to the longitudinal bending in the panels. The shear connectors may be used to transfer the weight of a non-structural width to a structural width. The GFRP connectors is used for thermal insulation purpose in precast concrete industry, such as plant precast, cast in place projects. The precast concrete sandwich wall is composed of inside layer, outside layer, and the thermal insulation. The thermal insulation is generally in the between the 2 concrete width. And the FRP thermal insulation connectors is used to connect these 3 layers, and it cannot only bear the weight of the insulation and outside layer, but also it can bear the wind load, earthquake load, and other kinds of loads. there are two cases will be presented today, and one of the case dealt with the thermal resistance of the GFRP connectors and the other with the shear capacity. The first case study is about the experimental investigation of thermal properties of insulated concrete sandwich panels with fiberglass shear connectors. And as we know that increasing economic and environmental cost of space heating and cooling have generated renewed interest in improving the thermal resistance of building envelopes. And at the same time, rising construction costs are driving designers to select prefabricated elements which can be constructed with higher quality control and in less time than the traditional construction. Precast concrete sandwich panels, also known as insulated concrete walls, are thermally efficient prefabricated elements that can address both of these needs. So the steel connectors are widely used in the industry, but also have the highest thermal conductivity of the conductor materials available. The concrete is also used to connect beads in full composite panels. However, a large area of concrete is required, which creates a large thermal breach. And over the past 2 decades, rising energy prices have encouraged the development of alternatives to traditional steel reinforced design. And glass fiber reinforced polymer or fiberglass materials have a significantly lower thermal conductivity than steel, which generally range from 1/60th or 1/3 to the 1/30th that of the steel, and require less breathing area than the concrete to hold the two widths together. So in the case study 1, the test setup was a hot box apparatus which used to determine the thermal behavior of the insulated concrete sandwich panel. The test cell had two chambers as shown in this figure, cold chamber and the hot chamber. The cold chamber was also known as the climate chamber, and which had a temperature of minus 4.3 degrees Celsius. And the other chamber is the hot chamber, which is also called as the metering chamber, that the temperature of that temperature was the room temperature at 25 degrees Celsius. And both the chambers were made up of precast concrete box culverts with octagonal cross section. As shown in this figure, the cross section of these chambers are in octagon shape. The space between these two chambers are adjustable for the various thickness of the test panels. So this space, this sandwich panel is the test specimen, which is used for the testing, and a circulating fan, as it can be shown here, adjacent to the heater, was used to increase the air velocity inside the hot chamber so that the air velocity was consistent across the surface of the panel. The test panels, as shown in this figure, had two width, one exterior width and one interior width, and they were separated by an insulation foam, and shear connectors, as shown here, the shear connectors were used to connect the two widths passing through the concrete studs. The back of each chamber, each chamber in the hot box apparatus was left open to allow the test panel to be installed. And this figure shows how the test panels were installed inside the hot box. The thermal resistance, or R value, is the ability of the insulation material to resist heat flow. The R value of each specimen in square meter Kelvin per watt can be determined from the average surface temperatures of the hot and cold sides of the panels and the amount of heat received from the metering or hot chamber. So in this equation, the A panel is the area of the test panel. T in and T out are the surface temperature facing the hot and cold chambers, and Q panel is the heat received by the tested wall. Now coming to the results from the case study 1, the two panels were constructed with similar numbers and dimension of the shear connectors. One was reinforced with steel connector, the other was reinforced with GFRP connectors. The GFRP connector panels, or fiberglass shear connectors panel, found to provide equivalent or better thermal resistance than the counterpart steel connectors panel due to the lower thermal conductivity of the glass fiber reinforced polymer compared to the steel, and therefore it's minimized the effect of the thermal breaching. The other conclusion or other result drawn from this study was the large glass fiber reinforced polymer connectors panel resulted in a 60% increase in the thermal resistance compared to the control panel. Control panel is the steel, the panel which is reinforced with steel connector. This result is the opposite effect of what we expected for steel reinforced panels, as the increased connector area of the steel would lead to more thermal bridging because steel is good, have a very good conductivity. Now the second case study talk about the in-plane shear behavior of the insulated precast concrete sandwich panels reinforced with corrugated GFRP connectors. And as I told earlier, the insulated precast concrete sandwich panel system are widely used commercially due to their economic advantages and superior thermal and structural efficiency. As discussed, the panel consists of exterior and interior precast concrete panel separated by a layer of rigid foam insulation. The presence of insulating layer enhances the thermal efficiency of the precast concrete sandwich panel system. The two discrete thin concrete beads help resist applied load by changing the shear transfer mechanism of a conventional concrete wall panel. And the figure below here shows the glass fiber reinforced polymer shear connector that incorporates a 45-degree angle to the shear plane and is 5 millimeter thick. And variable of the GFRP connector was used to investigate the toughness of the glass fiber reinforced polymer shear connector, where its pitch, height, and width. The specimens were supported vertically at the bottom edges of the two concrete. Here, the specimen is supported vertically at the bottom edges of the two concrete outer beads of steel blocks. A displacement rate of 5 millimeter per minute was used for the specimen. A vertical load was applied through the load cell and steel block in line with a 1000 kilonewton hydraulic jack to the top surface of the inner concrete bead to produce direct shear force across the interfaces. And the failure mode after the test wire, the strength of the panel reduced after maximum loading, followed by failure of the shear connector, and shear cracks in the insulation and delamination of the concrete and insulations were observed. As the displacement increases, as the rate of the displacement is increasing, the load is gradually decreasing. The specimen failed with the pullout of the shear connectors when the embedded length was not too long enough. The results drawn from the case study 2 were the increased width. The variable of the GFRP connector was used to investigate the toughness of the GFRP shear connector or its pitch and width, and an increase in the width of the corrugated GFRP shear connectors tend to increase the stiffness and strength of the specimen. And with the increase in the pitch, the in-plane shear strength increase, resulting in the high tensile strength of the shear connectors. So from these two case studies, what we found that in the first case study, the thermal resistance of the GFRP connectors is better than the steel counterpart steel connectors. The GFRP connectors, even with the increased size or larger size of GFRP connector is used, it will provide a better thermal resistance as compared to the steel connectors. And in the second, the shear strength of the GFRP connectors provide a better insight into how much amount of pitch and width and height of the GFRP connector should be used in the precast sandwich wall so that it can provide efficient or sufficient shear strength. So there are, as I told earlier, we have 3 different types of SFT connectors, which can be used for different construction projects, like in insulated walls, slabs, or precast elements. And these bars can be modified according to the project requirement. So in conclusion, due to the corrosion resistance, lightweight, and magnetic free nature of FRP connectors, it can be used in construction, replacing the conventional steel connectors. The GFRP connectors, precast insulated sandwich panels, can provide equivalent or better thermal resistance than the steel connector panels due to the low thermal conductivity of the GFRP compared to the steel. And finally, the large size of the GFRP connectors in precast insulated panels provide better thermal resistance, which is the opposite effect of what would be expected from steel connectors, as increased steel connectors area would lead to more thermal breezing. Thank you very much for your kind attention, and I am here to address any of your queries. Thank you.